you're in trouble. So knowingly or unknowingly, willingly or unwillingly, you guys walked into probably the deepest biochemistry talk at KetoCon. And I think KetoCon put it on Sunday as the last talk in the breakout section, just so that you guys actually couldn't ask for full refunds. So what's the roadmap for today? The roadmap is going to be mitochondria. I'm hoping, if I do my job right, you guys are going to learn why the mitochondria is so important. You're also going to get into the biochemistry of energy production. And then at the end, we're going to zoom out, and we're going to see how this applies to everyday life. And so that's the part that I really, really want to hone in on. I don't want you guys to think of this as a biochemistry lecture just for the sake of biochemistry, right? Because that doesn't do me any good, and it certainly doesn't do you guys any good. I really want you to think of this as a schematic or a blueprint to the human body. That's really what I'm trying to get across. So as we go through this, think of these concepts. Don't think of the words. Don't think of the terminology. Just think of how is this going to apply to everyday life. And again, if I do my job, that's what will happen. So my name is Jay. Some of you guys may know me as Perpetual Health on Instagram. I have a master's degree in science, clinical human nutrition, a clinical nutritional specialist once I take my boards, and I'm a functional nutritional therapy practitioner. So I think that's all the letters up there. So just so I can read the room a little bit, can you guys tell me who knows what, did I not turn this on? Ha, thank you, sir. Mitochondria. Anybody not know what the mitochondria are? Okay. Actually, I give you guys so much credit for being here. That's incredible, because I sat in your seat and I listened to people talk over my head 6 years ago, and I figured, it sounds really important. I think I want to understand what they're talking about. So I went back to school and I figured out what they were talking about. So I really appreciate that. So the mitochondria from high school biology, like the 10,000-foot view, it's the powerhouse of the cell, generates energy. That's mostly what it's known for. They call it an organelle. An organelle is just a fancy term for, if you think of the cell as a house, you can think of an organelle as like a room inside the house. It's a membrane structure inside that cell that's separate from the rest of the cell, but it works in conjunction with the cell, and that's all it is, okay? So, but what does it do? That's even more important. So again, we look at the top, you see ATP production, and that's what we're mostly going to talk about, but again, to illustrate just how important the mitochondria is, you can look at any one of these other parts of the wheel. Heme synthesis, apoptosis, which is programmed cell death, so that when cells become damaged, they don't become cancerous. You have sex hormone synthesis. You have literally every function in the human body, mitochondria will take part in this. But we're going to mostly focus on energy production. But I put that in there just because I wanted you guys to understand that mitochondria is not just the powerhouse of the cell. It really does sell it short. Now I'm going to impress you with mitochondrial facts. Well, I'm not going to impress you. The mitochondria are going to impress you. So 80 to 2,000 in any particular given cell, although there are some neurons that are estimated to have millions of mitochondria in each cell. ATP is generated every second of every single day. No ATP, no life. ATP is adenosine triphosphate. That's the energy currency of the human body. A resting cortical neuron consumes 4.7 billion molecules of ATP every single second. It's so important that the mitochondria makes up 25% of cell volume and 10% of your body weight. So if you weigh 150 pounds, pick up a 15-pound dumbbell, that is your mitochondria. That is the weight of your mitochondria. But, let's see, 1 billion will fit in a grain of sand. So, we think about the cosmos and think about how vast it is. So this is sort of the opposite side of that. Think about how amazing it is, all that work that's being done, and 1 billion will fit in a grain of sand. Now, the downside is that mitochondria are very susceptible to nutrient deficiencies, toxins, environmental damage, and over time, mitochondrial DNA damage will accumulate, and this leads to energy loss and fatigue and those kinds of symptoms. So take a moment just to think. I said mitochondrial DNA, mtDNA. So you may say, well, is that the same as my regular DNA? And the answer is no. Your mitochondria has its own DNA, and we don't get a chance to go into that here, but the basic story goes is two cells really loved each other, and they got together, and the bottom line is that the mitochondria retained its DNA, and in exchange for us protecting it from the environment and providing it nutrients, it gives us the energy to do life. So it's a pretty good relationship, but it's also why it's so important to live a healthy lifestyle and eat healthy food. Because again, you're responsible for these little bacterial passengers. So just think about that next time, and I'm hoping to build on this and give you guys a reason why the mitochondria are so important. But what happens when things go wrong? So you can see on the two outside, you see polymorphisms and aging. Polymorphisms is just a fancy word for DNA mutations. There's nothing we can do about them, but epigenetically, which is the expression of the genes, we can change that with lifestyle and we can change that with diet. Aging, we can't really solve that. If anybody does, please come see me after class. But in the middle, I want you to look at overloaded free fatty acids and hyperglycemia. So that's the metabolic aspect of this. So overloaded free fatty acids and hyperglycemia would be things like high blood sugar levels, high triglycerides, the kinds of things that doctors will often talk to you about. That's metabolic, the beginning of metabolic dysfunction. And what that leads to is the next step, which is ROS, that's reactive oxygen species. They're a normal part of cellular respiration, but if the creation of them outpaces the cell's ability to handle, we have problems. And so that leads to the next step, which is a reduction in mitochondrial biogenesis. Mitochondrial biogenesis is the creation of new mitochondria to handle this workload. And then an increase in DNA mutations. And we'll see as we go, those mutations can cause the mitochondria then to, again, start functioning poorly. So this cascade leads to what we call mitochondrial dysfunction, and that leads to another feedback loop. We have more reactive oxygen species. We have a decrease in ATP, which is the energy currency of the cell, and we have a decrease in beta oxidation. That's using fat for fuel. It's a pretty important thing, especially in this community. If you're living a ketogenic lifestyle and you are eating fat and you want to use your own body fat, which is what a lot of us want to do, but you're struggling in the mitochondria department, that may be where some of the problems exist. And then finally, we get to this bottom level where we start to see the manifestations that we recognize. Insulin resistance, cardiovascular disease, diabetes, and we just love labels. So this is a really interesting chart because what it shows you is that mitochondrial dysfunction, you can't look up any of these diseases. You can't go through the pathophysiology and not find mitochondrial dysfunction, at least as a player in the pathogenesis. So this is a little soapbox moment, but I think we should stop thinking of diseases as disease X requires treatment Y, which is either maybe a pharmaceutical or a surgery, and at least begin to think if we address mitochondrial health, then we may be able to at least mitigate, or in some cases, reverse disease. So again, I hope you're starting to see why I chose mitochondria. You might be thinking, well, why? He's not even choosing a cell, he's choosing a part of the cell to talk about, but this is why. Okay, now comes the biochemistry. Just nudge the person next to you. Everything's going to be fine. I'm gonna take you all through this. Everything's going to be just fine. We're going to do it from a really high level. So if there are any biochemists in the audience, I'm going to skip some steps, a lot of steps. So let's start at the top. Fats, carbohydrates, and proteins. That's your meal, right? That's your steak, your sweet potato, your olive oil. I just want you to understand that through a whole series of biochemical processes in the stomach and in the duodenum and the small intestine, these foods have to be broken down into their individual constituents. So fats become fatty acids, carbohydrates become simple sugars, proteins become amino acids. And if you notice in the boxes, I can't use my laser pointer. If you look in the boxes, you see B vitamins, you see lipoic acid, you see carnitine. This is why we can't focus strictly on calories. This is why it's so important to understand that micronutrients matter when it comes to your diet, okay? So really think about that. These foods have no chance to produce energy if you don't have adequate cofactors, which are the micronutrients. So the first thing I want you to remember is that food becomes a molecule called acetyl-CoA. That's all I really want you to remember from that top half of the slide. Acetyl-CoA is the entry point to something else you may have heard of called the Krebs cycle. Here it's labeled the citric acid cycle. It's also called the TCA cycle because science just loves to label things. So food becomes acetyl-CoA, enters the Krebs cycle, and the point of the Krebs cycle, which is, again, another series of reactions that has cofactors like iron, magnesium, B vitamins. You think of magnesium as a calming mineral, right? It brings us down. Well, it's also necessary for energy production. So again, I just want you to think micronutrients, right? Quality, food quality matters more than calories. So food becomes acetyl-CoA, goes through the Krebs cycle, a series of reactions. What's the point of the Krebs cycle? It does produce a little bit of ATP, but not really much that we need to worry about. But the idea is to produce two molecules, NADH and FADH2. Don't worry about what they mean, but that's the point. Food becomes acetyl-CoA, goes through the Krebs cycle, becomes NADH and FADH2, and it's going to deliver electrons to the next part of energy production. So I feel like everybody's with me. I don't see anybody nodding off. Okay, so we've taken that Krebs cycle, and now you can see that circle. We've just shrunken it down inside the mitochondria because I want you to see where we are. And I didn't mention this before because I wanted you to have this slide to reference. The mitochondria is actually a two-membrane structure. It's really important. On the top, you've got the outer membrane that faces the cell cytosol. You've got the inner membrane space underneath it. Then you've got the inner membrane, and that's where the electron transport chain sits, which we're going to talk about next. And then that Krebs cycle or citric acid cycle is in the matrix. The matrix is in the very middle of the mitochondria. So what is the electron transport chain? Basically, it is a series of protein complexes that sit on that inner mitochondrial membrane. And we're going to label them just by number. And in most scientific papers, you'll see them labeled by number. They do have names, but it's not really worth it because I don't remember them half the time. So we have complex 1, complex 2, complex 3, complex 4, and then if you go all the way over to the left, you'll see complex 5, also known as ATP synthase. We'll call that ATP synthase because there's a reason for that. But the rest of them are just complex 1, 2, 3, and 4. And so you remember from the Krebs cycle, what was the point? It was food, acetyl-CoA, goes through the Krebs cycle, creates NADH and FADH2. NADH and FADH2 are going to hand their electrons to complex 1 and complex 2, respectively. They're just going to hand off the electrons. And what happens to those protein structures is they go from a low energy state to a high energy state. The electrons supercharge these protein complexes. The next thing that happens is coenzyme Q. You may know the supplement CoQ10. This is where that lives, on the electron transport chain. It's going to take the electrons from 1 and 2, and it's going to hand them off to complex 3. So we're playing a game of hot potato here. Complex 3 is going to hand its electrons off to complex 4. And now 4 doesn't really have a partner in this dance, so it's going to hand its electrons off to the final electron acceptor, which is oxygen. That's why we breathe. So oxygen combines with these electrons and combines with hydrogen protons that are in the matrix, and we get metabolic water. So your food has just become water. It's pretty cool, right? Now you're saying, okay, great, Jay, we made water. What's the point of electron transport? So we're going to back up one step. Remember I said when the electrons pass down the chain, every time they pass to a protein complex, they are supercharged. They go from a state of low energy to a state of high energy. In that high energy state, the proteins actually conformationally change. They change their structure. And at that moment, they open up a pore. And when that pore opens up, hydrogen protons that sort of exist, they exist in an equilibrium on both the matrix side and the intermembrane space side. But now what happens when those pores are opened up, hydrogen protons are actually pumped through the protein complexes up into the intermembrane space. So now what we have is this high concentration of hydrogen protons up in the intermembrane space, which are positively charged, and we have a much more negatively charged matrix. So to bring it into the real world, because this is a really interesting and this is a point that I think will help you understand what I'm saying. If in your everyday life, can you think of anything that is a positive charge and a negative charge separated by a membrane as a store of potential energy? You can just yell it out if you know. Yes. It's a battery. So the mitochondria is a battery. And what happens if you take your battery out of your car or your battery out of your electric can opener or your battery out of anything? You have a useless piece of plastic. So I think, or if your batteries start to drain down, that utensil, that product won't work anymore, or it'll start to suffer. So think about that. As your mitochondria wear down, the body starts to suffer. So this is sort of the idea that I'm trying to get across. So one final step, and then the biochemistry is done. You guys are doing great. So we have this positively charged intermembrane space, lots of hydrogen protons, and only complex 1, 3, and 4 pump protons. That's important to know. Number 2 does not pump protons in this little game. I'll tell you why later. But so now we've got this electrochemical gradient is really what it's called. And nature does not want that. It wants equilibrium. It wants to push those hydrogen protons. They want to go back into the matrix. So we have now complex 5, ATP synthase. That's where energy production finally happens. ATP synthase is going to allow those hydrogen protons back into the matrix. But there's going to be a cost, like paying a toll. The cost is going to be a molecule of ADP, which is adenosine diphosphate 2, will be attached to a phosphate to make adenosine triphosphate 3. That is the energy currency. So that protons going through ATP synthase, it's called the proton motive force, is going to cause ATP synthase to attach that phosphate head, and now we've got ATP. ATP can be shipped off to other parts of the cell to do work, whatever the energetic demands of the system are. So it's amazing. Your food doesn't give you energy directly. Your food gives you energy by way of this whole process. So again, this is why the mitochondria are so important, because if it becomes dysfunctional, you can eat all the quality food you want, but your mitochondria can't use it as energy. And your body can't use it as energy. Okay, I get everything I wanted there? Yeah. So this is just a really cool slide that shows you all, you're not going to be able to see all these little things, but these are, B vitamins, melatonin, caffeine. This is another representation of the electron transport chain. Complex 1, 2, 3, 4, and ATP synthase is on the far right. All of those nutrients interact with each one of the complexes, so they can negatively or positively impact those complexes. So this is where I'm telling you that the things that you do in your everyday life, and that's where we're going next, are really going to impact how well your cells can use energy. I put this in here because I think you guys get the slides afterwards, and I really want you to be able to see this stuff. So this slide, so now we're done with the biochemistry. Yeah, leave no man behind. Okay, so mitochondria and immunity. This really doesn't fit in this presentation, but it kind of does, and this is going to be my soapbox moment, that every immune cell uses ATP as energy. And on the outer membrane that faces the cell cytosol, there's something called MAVs, which are mitochondrial antiviral signaling proteins. They recognize viruses. And then the mitochondria is able to orchestrate an immune response that's appropriate to the invasion. Do you all remember all that mitochondria talk over the last 3 years during everyone's favorite viral outbreak? Me neither. Weird, huh? I'll just leave it there. So now let's get into the everyday things that we can do. So mitochondria and light. So now I want you to really picture that electron transport chain. And I'm going to go back to that picture periodically so you can see where we're going. Complex 4, I told you they had other names. It's also called cytochrome C oxidase, but complex 4 is a photoacceptor. So certain nanometers of light will actually be drawn into complex 4. And when complex 4, think about this, right, what we just talked about. Complex 4 is now excited by light. And what it does is it starts pumping protons more efficiently. And when that gradient is established more efficiently, energy can be produced more efficiently. So red light therapy, next time you're standing in front of red light, it can actually help provide you with energy. So it's not just food that provides you energy, light provides you energy as well. And then, of course, wound healing and cell proliferation, that's sort of the downstream effect, but you're stimulating the mitochondria, and that helps the healing process. And I think here I show you, so between 600 and 850 nanometers of red light, that's what will get into the mitochondria to actually help complex 4 pump more protons and create more ATP. So that's, just wanted to show you complex 4 on the far right. That's the one, that's your photoacceptor. That's the one that loves that red light therapy. So when you're standing in front of a red light, I want you to think complex 4 is like, thank you so much. This is wonderful. Okay, antibiotics and mitochondria. So we got to look at some negative things. Antibiotics save lives. We wouldn't want to live in a time without them. But they also impair electron transport chain complex activity. Specifically, complex 1 and 3 are reduced by 25 to 40% respectively. And they can also, so this can feed back and start creating more reactive oxygen species, and that can cause an elevation in 8-OHDG. That is 8-hydroxydeoxyguanosine. It is a marker of DNA damage. So that's a sort of, you think about it, again, antibiotics save lives, but they're not without a cost. And you can measure that in the urine. Organic acid testing can measure 8-OHDG, and they can tell you sort of how the body's handling everything that's going on. So complex 1 and 3. Remember I told you complex 2 doesn't pump. So complex 1, 3, and 4. So now you've got 1 and 3 that are compromised by antibiotics. That's 2 out of your 3 pumping protein complexes. So again, antibiotics save lives, but they're not without a cost. So what can you do? You can take N-acetylcysteine. That's a precursor to the body's endogenous antioxidant, glutathione. That will actually help rescue mitochondrial respiratory activity, and it can actually even reduce the DNA damage that's incurred. So my protocol for if I ever had to be on antibiotics is pre-treat with NAC, and then maybe some, because antibiotics are a nuclear bomb essentially, so maybe take some whole food probiotics like sauerkraut, kefir, things like that, just to sort of reseed the gut. But in terms of the mitochondrial damage, NAC is a powerful tool. If you need to be on antibiotics, take it beforehand. Saturated fat, everyone's favorite topic. So C18, stearic acid, is found in meat and dairy and cocoa beans. So this actually helps regulate mitochondrial function, which is actually really cool. And what we see is a drop in long-chain acyl carnitines. So carnitine is sort of the chaperone that helps bring fats into the mitochondria so they can be used for beta oxidation. Again, another really important thing for ketogenic diets. If you're eating a lot of healthy fats, you want to have those mitochondria running, and some of you may even think of carnitine as a supplement you can take, and it is. And what we see is this drop in acyl carnitine shows us that the mitochondria are really loving to utilize the saturated fat as a fuel source. And this paper is amazing because it actually says, I pulled the quote, it's associated with a reduction in blood pressure, improved heart function, and a reduced cancer risk. Saturated fat. You don't hear that on the television. And that's probably due to a process called mitochondrial fusion and fission, and we can't really talk about that today, but that's basically, if you know what autophagy is, which is the process by which cells clean themselves, and mitophagy is specific to the mitochondria. And so even I think within 3 hours of this paper, if I'm recalling correctly, intake of stearic acid increases mitochondrial fusion. So when it cleans out all the sort of damaged parts of the mitochondria, then the mitochondria fuse together to make more robust and efficient mitochondria. And stearic acid actually does that. So don't tell me saturated fat's bad for you. Sleep and mitochondria. A lot of words on this slide. Basically, what's happening here is even one night of sleep deprivation, which is experienced by roughly 20% of shift workers, can cause a decrease in glucose tolerance and also a decrease in mitochondrial respiratory function. And this just basically says same thing happens after a few nights, same thing happens after 120 hours. So poor sleep is bad. And that's only defined as 4 hours of sleep, which I'm sure a lot of us have it's happened from time to time. So the one thing you can do here, the most important thing you can do, exercise. And it doesn't have to be, actually, I wouldn't go to the gym for 2 hours because who wants to do that on 4 hours of sleep? But something as simple as a 20-minute Tabata training, high-intensity interval training, can rescue both glucose tolerance and mitochondrial function. And you're going to see why in a moment, because next we're going to spend a couple slides on exercise in the mitochondria. But so the other thing is when you're lacking in sleep, what I would say is really be careful of your cravings because you will be driven to eat sugar and carbohydrates when you have lack of sleep because the body's really looking for a super quick source of energy. So pack your food the night before or get a 20-minute Tabata session in and you will thank yourself. Because exercise is mitochondrial medicine. That's the last point there. I just love that line. But it's a powerful tool for mitochondrial biogenesis, which is, again, the creation of new mitochondria. In the brain, it's specific to a pathway called PGC1 alpha, which is the master regulator of mitochondrial biogenesis. So now we're going back to the battery thing. So at any given time, you've got about 250 grams of ATP in a cell, which is the equivalent of a AA battery. And remember how many mitochondria are in each cell. So I mean, you are a walking, talking battery. You're a few more things than that, but so now here's a really cool thing. I wish I could have time to bring you guys up here, or a few of you up here, but think about the electron transport chain. And if I brought 3 of you up here to represent complex 1, 2, 3, and 4, and we all stood 5 feet apart, and we played that hot potato game with the electrons, right? How long would it take to get the electrons from one end to the other? Maybe 5 or 6 seconds if we were all standing 5 feet apart, right? What if I said, let's all stand shoulder to shoulder and pass that hot potato down the electron transport chain? Well, it's going to get there a lot quicker, right? So exercise does this amazing thing to the electron transport chain. It helps create something known as a supercomplex or a respirosome. And essentially what that does is it pulls the electron transport chain in tighter. And it allows for more efficient electron tunneling and then therefore more efficient proton pumping into the intermembrane space, which creates that electrochemical gradient faster and produces energy faster. So now you can kind of see why exercise may fix the problem with lack of sleep, because the problem was decreased mitochondrial respiration. Well, now we have more efficient electron transport chain function, more efficient tunneling, more efficient proton pumping, and more efficient energy production. So exercise is, glyphosate. You guys all know what glyphosate is? Yeah. This is why we buy organic. I've done whole podcasts on glyphosate, and so I had to choose just 3 things. So one is it disrupts membrane potential in the mitochondria. So remember, that membrane is separating those charges. And so if you've got protons that are leaking through a leaky membrane, what are they not doing? They're not producing energy through ATP synthase. So you've got diminished energy production from the membrane point of view, but it also depresses complex 3, which is one of your 3 pumping protein complexes. And remember I told you before that complex 2 does not pump protons. Well, this point 3 is why. Complex 2 is where the Krebs cycle and the electron transport chain connect. The enzyme succinate dehydrogenase is contained. It's an enzyme in the Krebs cycle, but it's actually contained in complex 2. So that's why complex 2 doesn't pump protons. But what's interesting is that glyphosate resembles succinate dehydrogenase on a molecular level. So it can actually attach to that binding site. And so then you've got issues with your Krebs cycle and you've got issues with the electron transport chain because complex 2 is where some of the electrons are handed off to CoQ and you've got sort of troubles coming from both ends. So even if any of this glyphosate stuff is true, we've got some serious problems, and there's a lot more. I wish I could go into it. And then the last thing I want to hit on is seed oils. So linoleic acid, omega-6, that's in industrial seed oils, is actually part of something called cardiolipin. Cardiolipin is a unique phospholipid that makes up part of that inner membrane in the mitochondria. So where that electron transport chain sits, 20 to 25, 15 to 20, close. 15 to 20% of the membrane is this molecule called cardiolipin. Well, if you go down to point 3, when you use seed oils, which are damaged omega-6s, damaged linoleic acid, they can incorporate into that cell membrane and into the cardiolipin molecule. And what happens then is you get that proton leakage. The protons are no longer creating energy through ATP synthase. They are leaking through the membrane. And so the cell starts to starve for energy. Rats fed a 20% sunflower oil diet for 4 weeks showed a few things. Loss of MNSOD, so that's manganese superoxide dismutase. That's the mitochondrial specific antioxidant. A 32% reduction in cardiac output and oxidative damage to the mitochondrial DNA. So now you're starting to understand. So we've got mitochondrial DNA damage. We've got reduced energy production. So a lot of people, you'll see it online, well, seed oils they're not inflammatory. I can show you a study that says they're not inflammatory, and that's true because I believe there's a genetic component to whether it shows to be inflammatory. However, when we talk about membrane structure, I think everybody is susceptible to that. So that's why I chose this to talk about when it comes to seed oils, because not a lot of people talk about this part of it. And I think it's more important than the inflammation. So what do? Well, I just chose 4 nutrients. CoQ10, we talked about CoQ10, right? It's an electron chaperone. It takes those electrons from complex 1 and complex 2 and it brings them over to complex 3. Carnitine, fantastic, helps shuttle long-chain fatty acids into the mitochondria for use as fuel. Creatine is also an antioxidant. Most people don't know that. And it can actually help rescue mitochondrial function. It can improve membrane potential and therefore ATP production. And then the last one I chose just randomly was B2. There's so many. It's a building block for complex 1 and 2, and it's involved in fatty acid oxidation. So you might say, but Jay, I don't want to take 4 pills. I don't want to take all these supplements. And I would say that's totally fair. So here's another set of mitochondrial support nutrients. And I just have to say, there's a war on red meat. And given everything I've just run you through, and I've told you that the mitochondrial theory of aging and disease is the most evidence-based theory of aging and disease that we have, and that red meat contains all of the nutrients that support mitochondria and then some in their most bioavailable form in a food that has been around since humans have been around. How exactly is red meat bad for you? They'll say cholesterol and saturated fat. Well, we covered saturated fat. I told you stearic acid is actually associated with a lot of positive health outcomes. And we didn't really touch cholesterol because I think some other people did that, but I'll tell you that cholesterol is part of the immune system. And it gets blamed for a lot of things. And we can certainly talk about that another time, but if all you've got is cholesterol, I'm going to say your paradigm is wrong. So red meat is not the cause of disease, it is part of the cure. So you did it. You made it. I'm so proud of you guys. You guys are fantastic. So if you would like to connect with me, you can go to perpetualhealth.co. I have myself and some amazing practitioners are putting together programs for people. We are running retreats that you can actually come in person, and you'll do a lot of learning like this in 30 minutes, but then you'll go outside and you'll experience whatever we talked about. Grounding, cold therapy, nose to tail chef cooking all weekend for you. So that's there. If you want to follow me on Instagram, same handle. I'm there active every single day. And then Substack is a place that if you feel like supporting me, you can, but everything is free there. I do sort of more controversial and longer dives, and I put video and audio up there as well. But those are my coordinates, and I really, the one thing you guys can't possibly ever get back is time, and the fact that you gave me, 30 minutes of your lives today is very much appreciated. So thank you very much. Right on time. That never happens. So I guess we got some Q&A. So the question was about metabolic water and dry fasting. So I haven't done a lot of specific research on that, but I think everything you just said is absolutely accurate. And I do know people who have been able to dry fast. That's one thing I've tried a lot of things. I like to self-experiment. But dry fasting is not one of them. But that is actually how you stay hydrated. I mean, that metabolic water is used in a similar way as exogenous water that you would drink. And it makes sense if you think about it, because the increase when you're fasting, you're really using your body stores for fuel. You're using that fat for fuel. So those long-chain fatty acids are producing a lot more metabolic water as well. So without looking at the actual research, I would hazard a guess that, I think fasting has a ton of benefits. I think if you are experienced with fasting, I would say, try a 24-hour dry fast and see how you feel. And I would also say that fasting with water is perfectly fine. I also fast with coffee and with green tea, but I actually like the idea of just straight up water fasts and always keep the minerals up. But yeah, your point is spot on, and the fatty acids will actually increase your metabolic water as well. So that's a great question. Well, these are good questions. So when I think of autoimmune, I think of the gut first, right? I think of repairing the gut lining. Let's talk afterwards. Let's talk afterwards, because I have a few ideas, but I think it's going to go into a lot of places, and like personal places. So I would like to talk to you about that. But I have some thoughts, and I think that while the mitochondria may not be the driver of autoimmunity, it's a byproduct, because the symptoms then can feed back on mitochondrial function, and as mitochondrial function starts to decrease, then you start experiencing more symptoms. So I would want to talk to you more about the gut aspect of it and how autoimmune was diagnosed, but it's a great question, especially because I showed that wheel where the mitochondria is at the center of everything. So thank you for the question. So melatonin, I'm just going to go back to a slide to show you. Melatonin is actually an antioxidant in the mitochondria as well. And from the research that I've read, I used to actually think differently. I used to think supplementing melatonin may be a negative because it may downregulate your body's ability to produce it, but that doesn't seem to be what the research actually shows. So I would say, obviously melatonin at night is more beneficial. I just want to see, because here we go. There is a specific complex, complex 4, actually, and complex 1. So increasing the activity of complex 1 and complex 4 are going to feed the mitochondria in terms of energy production, but then you're getting the double benefit of actually having it be an antioxidant. So I would say that that melatonin is probably a worthwhile supplement for the mitochondria, and you just have to take it at the appropriate times and the appropriate dosages. But yeah, I mean, it's one of the things I think I pointed out when we went past this slide. But melatonin, most people think of it as just a sleep aid, but it actually has electron transport chain benefits as well as antioxidant benefits. So it's a great question. You and I are a lot alike. I don't like to, as I said, I sat in seats at a conference 6 years ago, and everything went over my head. And I didn't understand why anything. And so I basically spent the last 6 years in school trying to figure out why everything. But then, then you, of course, you open that door, and what happened to me is I realized how much knowledge there is to attain. And so I never positioned myself as an expert. I positioned myself as a lifelong student. And so these questions always then spur things on for me. And I'm never afraid to say I don't know, because I'm just a guy. Yeah, so linoleic acid has a half-life of about 680 days, which means it's going to last roughly 4 years in the body. So that process can be accelerated, though, by fasting. Anything that upregulates beta oxidation, you'll be able to get rid of those. So that fasting has a lot of benefits. So that's what I would do for that. Although you are sort of at the mercy of just your metabolic state, right? Everyone's body's a little different in how quickly you can get rid of those fats out of the membranes. So just to back up a second, the fats that you intake in your diet have a direct correlation, and they make up your cell membranes. So when you eat seed oils, if people say, well, I only go out on the weekends and eat these things that have canola oil and sunflower oil and all these things, well, that's great, except the fact that, it's like, I'm trying to think of an analogy, but you're never going to get ahead of the game because you're always adding them in, and some of them can take 4 years to be depleted from the membranes. So it's one of those things where I tell people, if you're going to do one thing, go cold turkey on those suckers. And I know it's hard because they're in everything out there in the world. If you go out to eat, that's why I'm a hermit. If you go out to eat, you're just gonna, you're just gonna be eating these things all the time. So that's one part. And then the first part of your question is, from everything that I've read, the energy production will decline based on the amount of double bonds you have in your fats. So saturated fats will help you produce the most energy. Monounsaturated fats are sort of in the middle, and then polyunsaturated fats cause a lot of issues in a couple of ways. One of the interesting ways that I'm just starting to research now is reverse electron transport. I'm going to get myself into trouble here talking about something I don't completely comprehend yet. But basically, there's a feedback mechanism when polyunsaturated fats, as opposed to saturated fats, are driven down the electron transport chain. And it has to do with the ratio of NADH to FADH2. Now you guys all know what that is. And so there's a physiological insulin resistance that's a positive thing with saturated fats. So that reverse electron transport tells the body, I'm full. I've had enough. So the insulin resistance in this case actually isn't bad. It's a protective mechanism to not allow more nutrients into the cell to create more reactive oxygen species and create more damage. Polyunsaturated fats seem to not, based on that ratio, they seem to not cause reverse electron transport. Therefore, there's no feedback mechanism, no insulin resistance, and so energy just keeps getting shuttled into the cell, and since it can't all be used, it will create reactive oxygen species, damage mitochondrial DNA, and so yes. Yeah. So that's just another mechanism that I've just started. I was consuming some of that stuff about a week ago, and I was thinking, if somebody asks me that question, I'll sound so smart, but So to me, again, just thinking off the cuff, what that says to me is it's similar to exercise, is that you've stressed it it's like a hormetic stress, a positive stress. And so now you understand where oxygen comes into that at the end of the electron transport chain as the final acceptor. And so most likely what I would imagine is that you'll see some adaptation to that, and even maybe the next time you do hyperbaric oxygen treatment, you'll probably feel better. But that to me, that's just like exercise, like a sore muscle. It's a temporary adaptation, and then in the end, you will be stronger because of it. Yeah, I mean, I'm a big fan of listening to the body, and if you slept better, and then and as over the next few weeks, right, start to pay attention to things like your energy levels, physical signs. I'm a big fan of, because very often the outside of the body can tell you what's happening on the inside. So that sounds to me like the perfect hormetic stress, and you just made complex 4 really happy because it had a whole bunch of places to dump those electrons off to. So you might even feel more hydrated too, like I said, because the other end product is metabolic water. So you may start to see your skin may not be as dry, or any of those things. That start to pay attention to those things. Well, yes, it's kind of all of the above. I see it as an overload of omega-6, right? In nature, omega-6 is very sort of rare, and in whole food form, it's, even if you're eating a real whole food diet, you're going to get some, and that's okay because it's essential, but you're not going to get very much of it. The processing is one problem because they're damaged in the processing. The second part is you're just getting an unnatural amount, so the absolute amounts are too high, both omega-3 and omega-6. So this is why I'm not a fan, to sidetrack just a second, not a fan of over-supplementing omega-3. Because we're talking about volatile fats here. And so you're not just trying to match your level of omega-6 to reduce inflammation. See, this is why I didn't want to talk about inflammation. I wanted to talk about membrane structure, because that is sort of a separate issue. So you don't want to be bringing up your absolute values. And like if you were to take sunflower oil, you could never eat as many sunflowers as it would take to create a tablespoon of sunflower oil. So I have a problem with the absolute amounts, and then I have a problem with the processing, which damages them, which then incorporates them into a membrane, which becomes damaged and then can't function the way it should. Yes, so oxygen can attach. So polyunsaturated fats have multiple double bonds that are available for oxygen to jump onto. And so those polyunsaturated fats, during the processing, become oxidized. They have... Yep, and you're disrupting the membrane, which is what's separating those charges. And so it's essentially you're sort of like draining your battery to use like a side analogy. And then that gradient isn't as strong, and then the creation of ATP isn't as powerful. So it's interesting because I've had people tell me that they feel more energy when they stop eating seed oils, but it doesn't have anything to do with their inflammation. So I think it has to do with this. You look really, no. So they're actually developing tests. One of the doctors that wrote my textbook, Dr. Pizzorno, he's working on affordable testing. So we use proxies now, like you can test CoQ10, you can test citrate synthase, which is just a proxy for mitochondrial density and function. So there are a lot of proxy measures. But the long story short is I wish there was. I would love a finger prick, like a keto mojo for mitochondrial function. Hey, maybe we can get on that. But yeah, unfortunately, right now it's sort of like more lab driven. You got to do really invasive things like biopsies and. Yes, and then that's why I assess things through the physical as well. If there's just if things are not right, I just say, okay, let's start with mitochondrial function, and then we'll just kind of go from there. No, and that was to the question at the back. I'm that's still bouncing around in my brain, but I appreciate it. So I'm not sure. I've never looked at any of the research, but I'm going to hazard a guess that anything that increases O2 levels is going to stave off things like production of reactive oxygen species because you're providing more oxygen as that final electron acceptor. So again, not looking at any research, I'm going to say that's one of the benefits of that. Yeah. I should have brought a notebook up here because some of these things I actually want to write down and look up later. Yes. But the key is, it's not, there's a lot that we can do about it, right? We can support. But yeah, we are mortal, as far as I know. But yeah, and so with age, the damage accumulates over time, right? Even if you're mitigating the damage, it's like death by 1,000 paper cuts, right? And so that does slowly happen over time. But I firmly believe that we are meant to live longer than we do. So I think mitochondrial function is at the core of that. I would say that's probably more due to direct stimulation of one of those protein complexes in the electron transport chain. So complex 4, which I guess by way of, it's going to be quicker to pump protons, and it's also going to be quicker to hand off the electrons to oxygen. So, an interesting combo therapy would be hyperbaric oxygen and red light therapy. Yeah, I'd have to think about it more, but it certainly seems like that's what's happening. You're getting your mitochondria may be really susceptible in a good way to red light, and that's good. That's good news because for wound healing and just for general mitochondrial function. So keep up the red light, I would say. I love hearing those practical kinds of things. I actually had a methylene blue slide, but I had to pull it out. From what I remember, it's actually an electron donor to all the complexes. And here's the other cool thing. It actually donates electrons, but it also helps accept free radicals. So it can actually act as an antioxidant and an electron donor. So it actually works in two different ways. Methylene blue is kind of amazing. I've experimented, as I said, I experiment with a lot of things. And so I have played around with it a little bit, but yeah, it doesn't seem to be complex specific. It is, it's sort of indiscriminate. It just donates electrons where they're needed. It actually, complex 3 is one of the complexes that's poisoned by cyanide. That's how cyanide poisoning works. And methylene blue has been known to be an antidote for cyanide poisoning. But it doesn't seem to be restricted to just complex 3. So, okay, I can't give medical advice. But I would say, if I had to choose one of the two, I'll just say I disagree. I'm going to be really politically correct, which is not like me. But N-acetylcysteine, so here's the thing. You could also talk to your doctor. You could just say, maybe I'll just try one and then the other and see where it is. I'm going to bet, if I had to bet my life savings, I would say it's the metformin that's causing the fatigue. N-acetylcysteine is a support nutrient, so I would sort of separate them and do a little self-experiment and see, what's happening. I know David Sinclair, who's a major longevity researcher, is a big fan of metformin. I am not. So I'm not sure. When I think of cold plunging, I'm thinking more of anti-inflammatory. Yeah, it's funny because I actually didn't put that anywhere in the talk, any kind of cold when it came to mitochondrial function. So I'm gonna plead ignorance on that one. But I do know that it does. So it does that too. So similar to exercise. Thank you. One of my lovely colleagues helps. Right. But it also can help form the super complexes. So more efficient electron tunneling and proton pumping. I actually would prefer just the N-acetylcysteine. So there's a lot of debate as to whether glutathione can actually survive the GI tract and not be broken up into the individual amino acids that make it up. But N-acetylcysteine is great because it's like you're providing the support nutrients and letting the body decide how much it needs. That's always I always go for the precursors because the body is infinitely smarter and it will know what to do with them. If I was to take them, I would definitely separate them, but I would always gear more towards N-acetylcysteine than glutathione in general. Do you have another? Many questions. Well, I'll hang around. Yeah, that's a great question, and I don't think there is a perfect answer. I use a really clean, concentrated mineral drop that has like all trace minerals and everything. What's that? No, I get one from Mike Adams, the health ranger. I love his lab because he tests all his stuff for heavy metals and toxins and things. And so my body lets me know when I'm mineral deficient. I get some of the worst leg cramps. Because I'm really active and I know, especially in the summertime, you're sweating a lot. So I know when I'm mineral depleted. And so I just usually put that in in some water or something. And in the summers, I'll drink a lot more mineral water to try to replenish minerals. And so, yeah, you do the best you can, but you're right. And magnesium is one that I notice if I don't take, I feel crampy. So magnesium is one I will take, but your point is spot on. And glyphosate, I didn't even get into it, but glyphosate is a chelator. So the foods that have glyphosate on it, they're grabbing onto those minerals and not allowing them to be absorbed into the body. So even if you are eating a food on paper that has the minerals, if it's sprayed with glyphosate, it's going to be a lot harder to absorb those minerals. And it doesn't bioaccumulate in cows either, glyphosate, which is why animal-based diets are so great. Thank you guys so much. Thank you.